Hello Calculus, this is the second part of the 3.1 video notes. In your notebooks, I just want you to copy down these notations for the derivative. You could read this as f prime of x or this is again just writing the derivative of f of x. Right. So similarly, this is also the derivative of f of x, which could also be read as the derivative of f of x with respect to x. I know this last part seems unrelated. Later in calculus, there's later in the book it's called multivariable calculus, and when we differentiate functions, sometimes you differentiate with respect to a different variable. That won't be relevant in Calc 1, but that is just it actually will be relevant at one point briefly, but just so you know, all this is saying is we're taking the derivative where x is the independent variable that we're taking the derivative with respect to. It's not going to affect us right now, but I just want you to be aware of it. This is also the derivative of y, which can be read as y prime. Or the derivative of y. And this is the derivative of y with respect to x. Sometimes people write, with respect to, they might just write WRT with respect to, but anyways. So, here's another example. Given the function the square root of x minus 3, use the limit method to find f prime. So, to find the derivative of the function, we take the limit as h approaches 0 of f of x plus h minus f of x over h as h goes to 0. So if this is my function, then what we really need to evaluate is the limit as x approaches 0. Now f of x plus h, the f of x is the square root of x minus 3, so it's the square root of x plus h minus 3 minus f of x, which is minus the square root of x minus 3 all over h as h approaches 0. So as we're trying to evaluate this, we have an indeterminate form. It'll be an indeterminate form if you plug in 0, but what we can do here is multiply by the conjugate. So this is a skill that we've done before, so let's just do that. X plus h minus 3 plus the square root of x minus 3. We're going to multiply the top and bottom by that. And when we do that, that's going to give me the limit as h approaches 0. So when I multiply the numerators, when we do this FOIL thing, right, that we've done a few times, the first two terms, the square root of x plus h minus 3 times the square root of x plus h minus 3, the squares will just cancel out because we'll have a square root squared. So we just get that. And then your inner terms cancel out, right? You're going to have negative, you're going to have the square root of x plus h minus 3 times the square root of x minus 3, and then you have the negative square root of x minus 3 times the square root of x plus h minus 3. Those cancel out. We've seen that happen a bunch of times. So then finally, when we multiply the last terms, those square roots go away because we end up squaring a square root, and then we're left with negative x minus 3 all over h times the square root of x plus h minus 3 plus the square root of x minus 3. Okay? So this negative, if I distribute it through, that makes that negative and that positive, which tells me that those x's will cancel out, those negative 3 plus 3's will cancel out. So now I have the limit as h approaches 0 of h divided by h times the square root of x plus h minus 3 plus the square root of x minus 3 as h goes to 0. Now if you recognize, like always, those h's divide out, which helps us out, because now if I plug in the limit, I'm going to have x plus, now I'm plugging in 0, minus 3. So that just becomes the square root of x minus 3 plus the square root of x minus 3, which is 2 square roots of x minus 3. So this is the derivative. This is the slope of the function. If you want to find the slope of this function at any point, you use this function down here. All right, next example. Given x cubed plus 2x, let's find the derivative of y with respect to x. So, again, that's just another notation for the derivative. The derivative, I'm going to try making that green all year. So the derivative of y with respect to x is the limit as h approaches 0 of f of x plus h minus f of x all over h as h approaches 0. So, in this case here, that's the limit as h approaches 0 of, so the function is x cubed plus 8, so instead of x cubed, it's going to be x plus h cubed. I don't know why I said 8, plus 2x. So x plus h cubed plus 2 times, instead of x, it's x plus h. So that's the f of x plus h part, minus f of x, which is just x cubed plus 2x, all over h as h goes to 0. So x plus h cubed, I'm going to do that on the side here just so we have it. I'm actually going to use Pascal's triangle, which I'll make a video for if you haven't already seen it. So we're going to use something that's degree, this is degree 0, 1, let's do it a little bit to the side. Degree 0, 1, 2, 3. So we're on degree 3 because I'm doing x plus h cubed. So 1, 3, 3, and 1 are my coefficients. So when I do x plus h cubed, I'm going to get a 1, 3, 3, 1. Those are my coefficients. My first term will be x cubed. The term before that will have an x squared. The term before that will have an x. And the last term will have no h's. The last term will have an h cubed. The term before that will have an h squared, then an h, and then no h's. So this is actually what you get when you do x plus h cubed. So that's going to give me x cubed plus 3x squared h plus 3x h squared plus h cubed. And then distribute the 2, so I'm going to get plus 2x plus 2h. And then distribute this negative, so then I'm going to get minus x cubed minus 2x all over h as h goes to 0. This problem might start to look familiar to you. Those divide out, or excuse me, subtract out, and those subtract out. So on the top here I have, this is the limit. I have 3x squared h plus 3x h squared plus h cubed plus 2h all over h. Now, if you recognize at this point, just like all these problems tend to do, there's an h on the top that I can factor out. That leaves me with 3x squared plus 3xh plus h squared plus 2 all over h. So I took an h out of each of those terms. Now my h's divide out. And so now that the h on the bottom divides out, I can actually plug in 0, and this term becomes 0, that third term becomes 0, and then I get a 2. So 3x squared plus 2 is the derivative of y with respect to x. Okay. Now we have the function 2 divided by x. And if I want to find the derivative of the function with respect to x, let's do it. That's the limit as h approaches 0 of f of x plus h minus f of x all over h as h goes to 0. So in this case, my function is 2 over x. So it's going to be 2 over x plus h. That's the f of x plus h part. Minus f of x, which is 2 over x, all divided by h as h goes to 0. So this might look familiar. We've done problems like this before. What I recommend doing here is finding a common denominator. So that common denominator is going to be x plus h times x. So this fraction here multiplied by x over x. This one right here multiplied by x plus h over x plus h. So now I have the same denominator. So now I have the limit as h approaches 0. So this is going to be 2x over x times x plus h minus 2x plus 2h. I'm going to distribute the 2 there over x times x plus h all divided by h. So now that I have a common denominator, I'm going to write the top as just one fraction. So this becomes 2x. Now be careful. So this negative, there's an implied parentheses here. So it's going to be a minus 2x minus 2h. A lot of people forget that that's a minus 2h there. All over x times x plus h. And this is all being divided by h as h goes to 0. But I'm actually going to do the keep change flip step next. Also recognize that the 2x's cancel out. So I have the limit as h approaches 0. I have negative 2h over x times x plus h. So keep that the same. Change the division multiplication rate, keep change flip. And then flip, think of this as h over 1 to 1 over h. So that was keep change flip. And now, nice enough, the h's divide out. Once that happens, now I can plug in 0 for h. So this becomes negative 2 divided by x squared. That is the derivative of f of x with respect to x. Okay. All right, is that it? Or yep, that's it. Okay. Anyways, thanks for watching the video. Make sure to subscribe, smash the like button, or ring the bell for notifications.